So we're going to quickly talk about a couple of factors that affect solubility. And the first one is agitation. So if you're trying to dissolve a solid into your solvent, if your solute is a solid, then if you increase the agitation, meaning if you mix it, you're going to increase the solubility of that solid in your solvent. So when you're making hot chocolate, for example, you take the hot cocoa powder, you dump it into the water, and then you don't just leave it. You stir it. That's agitation. The second factor is temperature. Okay, so if you increase temperature versus if you decrease temperature. If you increase temperature, then the solubility of a solid is going to increase. So if you think about it, when you're making hot chocolate, the reason why we call it hot chocolate is because we want to increase the solubility of the solute, your cocoa powder, into your water or your milk. And so if you increase temperature of the solvent, then the solute is better able to dissolve. In contrast, if you decrease the temperature for a gas of the solvent when you're trying to dissolve a gas, that increases the solubility. So if you think about it, if you have ever had soda in your life, the best type of soda is cold soda. And that's because the gas is able to stay dissolved in the water better than if it were warm, because once you start to increase temperature, the solubility of a gas in a liquid decreases. So you start to lose your carbon dioxide bubbles and it suddenly becomes flat. So that's why we leave open bottles of soda in the fridge, just to encourage the gas molecules to stay dissolved in the liquid. Okay? And so now what you guys are going to do is you're going to use your textbook in order to look at some of the quantitative ways of representing solubility and concentration.
So there are a number of different ways to actually measure concentration, but the one that we're going to be using in this class is molarity.
So molarity is instead of volume or mass, it's the moles of your solute divided by liters of your solution. Okay? The units for molarity are capital M, okay, and that's pronounced molar. So if I have a 10 molar solution, that's describing the molarity. Okay? So for this problem, it says calculate the molarity of a solution that has 0.127 moles of sucrose in 655 mils of solution. Okay? So here I already have my moles of solute. In a lot of problems you'll be asked, calculate the molarity of a solution that has a certain number of grams of solute. So in that case, you would have to convert from grams into moles. But here I'm already in moles, which is awesome. So my molarity equals my moles, 0.127 moles, divided by, well, I need to be in liters of solution. So I'm going to take the 655 milliliters, and I'm going to convert that into liters. If you can do that in your head, awesome. If you can't, that's fine. But get used to needing to do that conversion because it's going to happen a lot. So they're 10 to the negative third liters in 1 milliliter. Okay, so I'm going to just end up dividing by 1,000 because that's what multiplying by 10 to the negative third is. So what I get for my volume is 0.655 liters. Okay, so that's what's going to go on bottom. That's my volume of my solution. Okay, and so what I get for my molarity when I do this, 0.127 divided by 0.655, I get, well, I want 3 sig figs here. I've got 3 sig figs here. So I got 0.19389. So I want to keep the 1, the 9, and the 3 is going to round up to a 4. So 0.194. And my units are molar, capital M. Make sure it's a capital M and it's molar. And that's it. Those are your molarity concentration calculations.